I'm Yuko. I am one of the Seaquarists with Seaquaria Ocean Education, and today I will be talking to you about ocean acidification and how you can recreate it in your kitchen. Ocean acidification is the result of carbon dioxide reacting with seawater, making seawater go from slightly basic to acidic. How do we know something is acidic or basic? We use the pH scale to measure it. The pH scale ranges from 0 to 14, with anything below 7 considered to be acidic, anything above 7 is basic. Our lucky number 7 here is considered neutral, so things that have a pH of 7 are neither acidic nor basic, like our drinking water here. A household item that is basic is bleach. It'll be on this end of the scale. And a household item that is considered acidic is vinegar on the lower end of the scale. Another really good example of something that's acidic is our stomach acids. When we eat a meal, our stomach releases stomach acids to dissolve and break down the food that we eat, allowing our body to absorb the nutrients. But when we're feeling sick and we have to vomit and you feel the burning sensation coming up your throat, that's actually our stomach acid coming back out, and the burning you feel is caused by that acid. When the ocean absorbs carbon dioxide, it makes the seawater more acidic. This can mean bad news for animals, especially animals like bivalves, animals with 2 shells. Animals such as oysters, clams, mussels, cockles, and scallops. This is because these animals use minerals available to them in the seawater to grow their shells, to build up their shells, which is their main form of protection. And when the acid starts eating away at those minerals not only available in the seawater, but on their shells, this leaves them with very thin, very weak, brittle shells. Not a very good time for them. What do you think will happen to them if they don't have a good, strong shell to live in? It is very difficult to imagine the process of ocean acidification in our oceans, mainly because we don't live in it. As much as I would love to live my entire life under the sea, I don't have the proper body parts for it. Instead, I'll be showing you how to recreate ocean acidification right in your kitchen. For the shell-shocked experiment, you will need vinegar, tap water, 3 containers, 3 shells of similar shape and size, 3 labels, and the shell-shock datasheet you can find on our Facebook or website, or you can make your own. We'll link those below. To start, label your containers with vinegar, tap water, and half vinegar, half water. Before we fill these containers, I want you to draw and/or write a sentence that describe what you think is going to happen to each shell when we put them into the 3 different liquids. This is called making a hypothesis, and it's a very important step in the scientific method. The scientific method are steps that every scientist follows when they're doing an experiment. We know that vinegar has a pH of 2, making it acidic. What do you think will happen to the shell sitting in vinegar? We also know that tap water is neutral and has a pH of 7. What do you think will happen to the shell sitting in tap water? Let's fill the containers. You don't need a lot of vinegar, just enough to cover the shell. Same goes for the next 2 containers. Next, we will have to practice patience. I want you to observe what is happening in each container and write a sentence or draw a picture that describe what you see. After that, leave the shells alone for about 10 to 15 minutes. Let's take the shells out and compare them. What differences do you notice about the texture and the color? I noticed that the shells that were in the vinegar containers are lighter in color and feel smoother, like it lost some of its texture. It seems like the vinegar dissolved the surface of the shell. Make sure you take some time to draw or write what you observe to complete your data sheet. I was curious to see what would happen to the shells if I left them in the vinegar and the water over the weekend, and this was the result. This is the shell left in tap water over the weekend. As you can see, there has been no changes to it. It still has the same color, thickness, and texture on the top of the shell. This is the shell left in half vinegar and half water, so the diluted vinegar solution. And as I'm touching it, it feels quite slimy and it's quite smooth. It's lost a lot of its color, and it feels a little bit thinner than before I put it into the solution. These last two shells here were left in vinegar over the weekend, and as you can see, the shell is much more brittle. I feel like I can snap it in half with just my 2 fingers. The edges is very brittle and rough. It feels a lot thinner, and it's also lost a lot of its color over the weekend. Thank you so much for tuning in to my ocean acidification video. I hope you learned a lot from this experiment, and I want you guys to also consider what other impacts ocean acidification might have on the wildlife in the ocean. Let me know down below in the comments. And share your results with us by hashtagging Seaquaria Learning and tagging us on Instagram at Seaquaria_ocean_education. I know it's a mouthful. Or tagging us on Facebook as Seaquaria Ocean Ed. Till next time, thank you!